Hi everyone. Welcome to StrawDesk, a full-stack support ticket CRM MVP that I built. The entire user interface is designed with a dark, modern theme using Next.js and Tailwind CSS, and it hosted live right now on Vercel. Right on the home dashboard, you can see our key metrics: total tickets, open, in progress, and closed. These metric cards calculate numbers automatically by querying our live backend database. Let's take a look at the deployment environment. The frontend is managed through Vercel and is connected directly to my GitHub repository, allowing for continuous integration. Every time code changes are pushed to the master branch, Vercel automatically pulls the assets, builds the project, and serves it globally across optimized edge nodes with zero manual downtime. For our backend and database infrastructure, I used Railway. Here you can see my two live service containers, a containerized FastAPI web server handling our logic and routing rules, and an isolated PostgreSQL cluster volume holding our relational data records. Now let's look at the source code context. Inside database.py, we use the SQLAlchemy ORM to manage database interactions cleanly. By executing base.metadata.create_write at startup, the backend automatically sets up its own tables on the live database if they don't exist yet. Below that, inside main.py, we register our FastAPI application server, configure global CORS middleware permissions, and establish clean routes to read, log, and update CRM items. Let's demonstrate a full end-to-end user lifecycle test. By clicking the Create Ticket button, we are taken to a clean form page. I'll enter the test user details, setting the customer's name as Akshay, adding their email, writing lagging as the title, and explaining that the website is slow inside the main body. When I hit Submit, the frontend sends a POST request directly to our live Railway API URL. The server validates the fields, saves it to PostgreSQL, and automatically routes us back home where our metrics adjust and our new ticket appears instantly at the bottom. To help triage engineers handle heavy workloads, I built highly responsive dashboard utility filters. Support agents can click the status drop-down to separate files, jumping instantly between open requests, active items, or closed logs. Furthermore, the search bar lets you look up records in real time. If I type in a query like Sohom, the dashboard grid filters down matching rows immediately based on strings found inside fields like names or descriptions. Clearing the query brings back the complete dataset dynamically. If an engineer needs to update an explicit case file, they can click directly on the ticket identifier link. This triggers a Next.js dynamic path route to pull deep contextual details for that item. Over on the Update control panel, we can easily shift the ticket state from open to closed. To make typing fast, I added preset template buttons. Clicking Request Logs or Escalate automatically appends text macros right into the internal comment field. Clicking Save Updates instantly pushes these changes to the database, which automatically refreshes the page and populates the activity logs history at the bottom to show our new system audit trailing smoothly. Returning to our home workspace. Lastly, I added an analytical reporting tool. Clicking the Export to CSV button triggers a client-side function that instantly compiles the active data rows into a clean comma-separated structure and downloads it as a local document. One core technical challenge I faced during deployment was configuring the cross-origin resource sharing settings within the unicorn startup command. I had to explicitly define the allowed origin host parameters on the production server to prevent the cloud backend from blocking incoming request payloads from our Vercel domain. The application is fully optimized, running live in production, and completely ready for deployment. Thanks for watching.